We're going to talk about the magnetic field, and a magnet is a device or any given material which it has a north pole and a south pole, and the magnetic field is going to travel from the north pole towards the south pole. And this is going to happen in this kind of materials which are magnetic, and you can actually see if you have any given metal, you can actually see this pattern, and in such a way that electric fields generate a force to particles. If I have a particle that is in a magnetic field, there will be a force, and the magnetic field is going to be denoted with the letter V. The force to a magnetic due to the magnetic field is given by a cross product. So we have the charge of the particle, and the particle needs to be moving, it needs to have a velocity, and it's a cross product with the magnetic field. So let's remember a little bit of the cross product. And the cross product that we are actually looking at right now is this one. So the magnitude of this given force is going to be given as the scalar Q times the magnitude of the velocity times the magnitude of the magnetic field times the sine of the angle between the vector velocity and the vector magnetic field. So for instance, if we have a magnetic field that is moving in such a way that is going towards this direction, this is the magnetic field, and the particle which enters in such a way that it enters towards this direction, then the angle that we are looking for is this angle. Well, it's the same angle no matter what, and it's this angle which is the angle between the vector velocity and the vector magnetic field. The direction of this guy is always perpendicular to the original vectors. So in this case, in order to be perpendicular, it has to go into the screen or outwards the screen. How do we know? Well, that's the sense, and it is given by the right hand rule. And in this case, since we have B cross B, we have to use the right hand rule, B cross B. We input our hand in B and close it towards B, and we can get the deduction that since our thumb is going to go towards the inside of the screen, this vector force goes towards the inward. In another example, let's suppose that you have B, which is the magnetic field, and it's pointing towards the outside of the screen, so towards you, and you input a particle, or there is a particle which enters with a velocity, and given the right hand rule, this particle will start to move, or the force when it enters is going to be towards downwards. So try to do this given the right hand rule, and it is the direction of your thumb. And also remember that you need 4 things in order to have force, which is, for instance, a magnetic field. You need the charge, so this has to have a charge, this particle. You need a particle which has a velocity, and you need to, for the velocity and the magnetic field and the velocity not to be parallel. Otherwise, if they are parallel, then this will cancel out. And remember, this is a cross product. So if you have vector v with component x and vector v with component x, y, z, both the three components, you should be the matrix, right? So just remember that. So since you are doing the cross product of b cross b, then this is going to be I, j, k, and you have to build the matrix as vx, vy, vz, vx, vy, vz, and then you can actually do, for instance, this times this minus this times this, and that's the I component. This times this minus this times this with a minus previously, and that's the j component, and the z component is the combination between this times this minus this times this, right? So try to remember that from a previous tutorial.